We're going to use RBDs in Houdini to create deformation destruction effects. Since I'm starting from scratch, this lesson will be broken down into shorter videos. In this first part, we're going to go over all the fracturing, camera tracking, and RBD simulation setup. In the next video, we'll swap out the low poly geometry for a high poly one, and you'll get to see the RBD deformations. And in the last step, we'll set up the UVs in Houdini, throw in some textures from Substance Painter, and you'll really get to see the scene come to life being rendered in Redshift. Basic concept number 6A, RBD Deformation. Let's start by dropping down a geometry node. Let's go into it, and let's drop down a tube. We're going to start fracturing this tube. I want a fairly long tube with the end caps on the ends of the tube so that this creates a watertight solid. It's a little short, so I'm going to pull it up by 2 Houdini units, so it's fairly longer. Now we're going to start fracturing this. So you want to keep your original geometry as low poly as possible. The polygons are going to increase exponentially when you start fracturing them. So you want to begin with something fairly low poly count. This right now is 24 points, which is pretty good right now. Next, let's drop down RBD Material Fracture node. Now let's also drop down an RBD Exploded view. I'm going to color this node black just because this is only for visual purposes. It's not going to affect our scene in any way. In the previous basic concept videos, I talked about different ways to fracture geometry. We're going to be using those guide points and using volume to control the fracturing. That means we're going to convert our tube into a volume, and we can do that by using the VDB from polygon node. Now what we want here is not the distance VDB. What we want is the density. So uncheck that and check the fog VDB. We're going to use a scatter node, and we're going to scatter points based on the density of this volume. We don't want a fixed number of points, so let's uncheck this, and what we want to rely on is the density scale. Let me turn on the points right now. It doesn't look like it's much right now, so let's template the tube. So that's very few points. What we can do is scale up the density by increasing this number to something crazy like 2000. That's quite a lot of points to work with. Now what we want to do is exaggerate these points into the tips. So the top and bottom parts of the tube will contain more points compared to the middle. Those are the areas that we're going to collide onto the ground. That's where most of the fracturing will occur. Now I'm going to control the density of the volume using a volume wrangle. I'm just going to copy this volume wrangle in here. Let me pull this out. Now, what are these two lines basically doing, though? A brief 30-second explanation. I'm taking the values of the y-axis, and I'm defining the density of the volume based on the y values. Higher the position it is in this tube, the higher the density. Keep in mind that we have a 0 point right here because this is the origin right here. We're going to get into the negatives down here. And in order to avoid all that, I do have an absolute sign here. And it'll flip everything, it'll turn everything negative into positive value, so I don't have to worry about the negative. The next issue is that this goes all the way up here in a linear step-by-step progression, which is not what I want. I want an exaggerated amount of points on the tips, so more on the tips. So the power function is exaggerating this power function here, which is the exponential. Taking the exponent to the power of 2 will exaggerate the value in math to one side, and which is what I want. I want it to exaggerate mostly to the tips. Now you're probably wondering, what is this division doing? Well, I'm grabbing the maximum values here, which is just the height. It's just the maximum value here in the y-axis, which is, it should be 1 right now because the total height of our tube is 2 Houdini units. So 1 here and then goes to -1 here. So the maximum y value would be 1. We take the current position of the y and I divide that by the maximum value. Well, what does that give me? Well, if you're right here, you're going to be 0.5 divided by 1. So that's just a percentage in the total height. If I were to increase this tube height to like 3, that would still, this percent would not change. It would still be the middle. If you're still in the middle, midway point, that gives me a nice number to work with. So we don't have to worry about the values changing to something totally different. We'll always get the same ratio. So that's the only reason of this. And then you throw everything into ABS is just the absolute, because I'm dealing with, I don't want to care about the negatives. Raising it to the power of 2, which is taking the exponent, it gives me a bias. I multiply it to a parameter. Well, why would I do that? Because this gives me a little bit of control. This scale gives me a little bit of control that I can tweak with. You can see if I want more points or less points. We want to start off with less fracturing just to get our simulation working first. And then we can increase this number a little later when we have everything working and when we're ready to do like a final render shot. So I'm going to keep this number a little low, and now I'm going to hook this up into the last input of the RBD material fracture, which is extra Voronoi points. Now you actually have to turn it on too. Don't forget that. Now I only want to fracture it once. So I'm going to remove one of these. It's doing it twice. So it's fracturing this and it's fracturing on top of the fracture points. So I want to remove one of these. Let's just press this X here and we'll just have one level of fracturing. I want to use the guide points that I have over here. So in that case, I'm going to remove the scattering points. I'm going to put 0 there. This is the random scattering that comes from the material fracture node. 0 there because I don't want that. Enable the input points, and it automatically fractures using the guide points, the Voronoi guide points that we've inputted in. Now let's take a look at how this looks like in the explode view. Now you can see that the pieces are more focused. We have smaller pieces up here. Let me make this black. So we have smaller blast pieces or fractured pieces on the top compared to the middle. Now these pieces are a lot larger. Now the next thing I want to do is set up some constraints. And now you need to know that the RBD material fracture comes with constraints by default. So in the constraints tab over here, you can see that it already has constraints all set up over here. I'm going to overwrite these constraints using the RBD constraints properties. It will overwrite the strengths of these constraints. It'll keep the polylines, but it'll overwrite the strengths. So this node just has a better UI, so I can see everything a little more clear. You can slightly make out the constraints, the little lines. First thing I want to do is enable the switching. When the glue constraints break, I want the constraints to automatically switch to a soft constraint. So I want to enable this. We're going to try and recreate that spaghetti constraint that we've seen in the previous basic concept video, except minus all the spring effect. So the key of creating RBD deformation, utilizing the soft constraint and its flexibility without the springiness. And what I want to do is lower down the stiffness just a bit so that there's room to budge for each constraint. So I'm just going to lower it down to like 5. The dampening ratio will remain the same because I do not want that spring effect. If you remember from the previous basic concept video, when you lower the dampening ratio, it'll create that spring effect like a spaghetti dropping down, and that you'll have that bounciness, but that's not what we want here. All right, let's drop down the RBD configure node so we can define some physical parameters or physical attributes for this for our fractured material. You can adjust this a little later. You want to get it working first, and you'll find that you're going to come back to the physical attributes and you're going to be tweaking this as you run the simulation over and over and over again. So let's drop down RBD Solver. I'm going to turn the grid back on and let's just run it. Okay, it just drops to the ground. For one thing, we want a ground for this tube to collide with. So let's come to the RBD Solver into the collisions tab and let's add a ground. Now the ground is actually intersecting with our tube at the moment. So we're going to actually change the position of the tube. Go back up to our original geometry and the scatter points. So we want the tube here to be a little above ground. Let's template this tube. Now we can't see it because it's right in the same place right now, but we're going to start moving this around. I'm going to throw down a transform node right here. Now let me make a bit more real estate. Template this. I'm going to actually move this up. Move the mouse over to the 3D viewport, press enter, while you have this transformation node selected, and that will give you this widget so you can just manually do it by hand. I'm going to lift it up so it's above ground, and I'm going to do something else. I am going to rotate this. so that it's heading this way. I'm going to be pushing or throwing this tube forward. So it's going to go this way. We're going to be adding some initial velocity and it's going to kickstart it in that direction. And then as the gravity pulls it down, it will collide and hit the ground, creating RBD deformation. Since we've moved our initial geometry here using this transform node, that means our scatter points over here are out of place. So let's template that transform. So you can see there's a huge, but this is not correct. What we need to do is that what I prefer to do is take this transformation node and I'm going to make a copy of this. Right click, actions, create reference copy. So it's going to do the exact same thing. And I'm going to hook it up to our guide points. Now, this and this is exactly the same thing, which is perfect. You might ask, why don't you just hook it up to the tube right up here? Then they'll naturally be in the same place. That's because the way that I create this volume wrangle, it's based on the origin. I'm using, it changes everything. Easier to create the wrangle based on the origin position. Right clicking the transform node and creating copy over here is fairly easy compared to reworking the vex. Hopefully you find that this method is more easier to understand. So let's see how the fracturing looks like. Take a look. Okay, that looks fairly cool. Let's go back to the RBD Solver and let's play the simulation. Okay, it just hits the ground. What we now need is some velocity to kickstart this and to throw it forward. I'm going to throw in some initial velocity here. Let's throw down a wrangle. I'm going to attach it over here. We need it in between the initial the geometry to be fractured right here. Initial velocity. You can use an attribute create for this. I'm just so used to using wrangles. It's just 2 lines. I need a vector. Velocity is in vectors. It's not a scalar value. So we need v at, because we're writing an attribute. So we're writing an attribute. And what is the attribute called? Well, it's going to be v, because v for velocity. And we're assigning it in, the velocity is going to go in towards the x direction. That's the positive z-axis. Is set. What the set function does, it creates a vector. So we want 0. We don't care about the x. We don't care about the y. We just want 1 for the z. And this will be the velocity direction. Put your semicolon. That defines the velocity. The next line I want is just a way to control the magnitude of velocity. Like I want a larger velocity or lighter velocity. Well, we can just multiply a scale v. And I'm going to multiply equal. So this is a shortcut. This goes multiply some value to it. You're going to go CHF scale. Now, after you have that, this little function here creates a parameter for us. And we're going to call it scale. Press this little button here and it'll automatically create the parameter down here. Now we can adjust this. So what we want to do here is, because I can't see anything, let's create that marker. Let's come over here, press the I want, now this V over here. Click this and it'll create that marker. So let's come down here and right click this. And here's the V. I want to see this. So it's marker, it's a vector. It should be showing up. Oh, because it's 0. So our scale is 0. That's because we don't see anything. Let's scale this up. Okay, there you go. There's our velocity markers. So let's increase. Now, scaling it up to 1 is not very helpful. So let's come over here, scale, and I want to change this range. And I want to change it to something like 20 so that I have a more meaningful slider. Now we can take this and we can slide all the way to 20. Now that might be a little much. So let's just start with 5. And we're going to have to test this a few times in the RBD Solver. I'm going to play this now. Okay, let's turn off the markers because it's getting in the way. Okay, for one thing, we don't have enough thrust or enough velocity to throw it forward. Like it's going like half a meter and it's dropping down. That's not anything. So let's increase the velocity and let's go over to something crazy like 85. And for one thing, I need to change the slider again so that we have something a little bigger than that. Let's go to 100 instead of 20. And let's try it again. Okay, that went really, really far. Let's try. That's pretty cool. That's exactly what you want. So that looks pretty cool. We can keep adjusting this. For one thing, we haven't tweaked the physical properties yet. So you can see that it bounces quite a lot. Bounces, it goes really high. Like here, it's spinning in the air a lot. What I really want, if it would collide more with the ground so we can get more interesting deformations or collisions, what we can do is come to the RBD configuration node, because we haven't tweaked that yet, and we can tweak the physical properties of our geometry. So we can tweak the density or the mass, and I want this to be a lot heavier. So let's go like 5 times as heavier. Bounce, I don't want it to bounce that high. I want it to keep colliding with the ground. So let's make this 0.2, and let's try the RBD Solver. Okay, let me bring back the ground. Okay, we're getting some nice collisions. So in order to help me view this, because I can't really tell when it's hitting the ground, trail node. So this is just going to help me visualize stuff so I can tell what's going on. Trail increment, I don't want it too close. So this is going to be that onion wrapping, how close you want the onion layers to be. I'm going to be like 5. Trail length, I want 20. So this is the onion layer that we're unraveling. So the trail increment is too far. Let's go like here, closer, and let's go with 40 instead. So it crashes here, and it crashes here again, and then it crashes here, which is nice. The more collisions we get down here, the more deformations we're gonna see. That is what we want. Now the next thing we want to do is create a camera tracker to track the moving tube. If I play this right now, play the RBD Solver. Now that goes out of camera view, so we can't get a close up while trying to like chase that tube down. Like that's insane. I've had to keep dragging this over in the viewport. So let's create a tracking camera. I'm going to take the results of our RBD solver, and I'm going to place down a time shift. I need the time shift between frame 1 before it starts moving and the current one, so that Houdini can calculate the offset and go like, oh, this tube has moved from here to there. Needs to be pointing to frame 1. So I'm going to remove Houdini expression by Control Shift left click on this parameter. I'll turn it to a normal parameter, and I want this to be fixed on frame 1. Now I'm going to just take this and just copy it. I'm going to group these 2 lines over here, pressing down Alt on the keyboard and left click and dragging over these. Here we have to actually bring back that Houdini expression. So let's go $F. I want the current frame. So this gives me the current frame where the fractured, it's falling apart. This over here, source out, is where it begins, right here at the origin. You can see that this is nice and clean. It hasn't hit anything yet. Come over here, hold down Control on your keyboard, left click this camera, and it'll create the camera at this view, matching your viewport. I'm going to move this out a bit. So make sure that this is locked on here. Hold down Alt on your keyboard and mouse drag outwards so I can get the zoom out a bit. Now, what we need to drop down here is an extract transform. This will extract the transformation between that out source and out destination that we created. Remember to unlock the camera when you're done so you don't mistakenly move the camera position. This is just a math thing that I want to calculate the offset between these 2 nodes from the source and to the current position in frame 24. So let's go over here, select the source and select the destination. So let me click this. Let's go over here. That's source node. Accept. Click this, sorry. Okay, select the destination. Now remove rotation because I do not care about the rotation at the moment. The camera does not need to know about how the pieces are rotating because we only need to know the position. So we're going to track the position of the camera. So uncheck this. Now I'm going to parent the extraction to the camera. Now let's go to frame 24. We're ending up somewhere. We don't see it in the camera. Let's come back to the geometry node and inside here, let's put the render flag on the out destination. Now let's play it. There you go. Okay, now we have this in the camera view. And you can change the offset position of the camera view by coming over to the camera here. Click this little lock, hold down Alt on your keyboard and mouse zoom out. So you can Ooh, okay, change it here and uncheck that. I took this frame and rendered it out in Redshift with textures and materials assigned to give you an idea of what it would look like when we're done the entire project. So in the upcoming videos, we'll finish this off by up-resing this geometry to a higher poly count, assign UVs, create very simple substance painter textures, and finally render it in Redshift in Houdini. Thanks for watching and sticking to the end.